Okay, for this case, we would like to identify how fast is the top of the ladder sliding down when it is 4 meters above the ground. So let's say this is our ladder. Now let us label some of the known quantities. So from the given here, the ladder is 40 meters long. So let's say this would be 40 meters. And then the bottom of the ladder is sliding away from the wall at the rate of 2 meters per second. So if this is the bottom of the ladder, and it's sliding away, therefore, this would be 2 meters per second. So the question is, if the bottom of the ladder is sliding away at a rate of 2 meters per second, how fast is the top of the ladder sliding down when this distance is 4 meters? So let us use some variables. Let's say this is our y distance, this would be our x distance, and then 40 meters is z distance. So you'd like to identify what is the derivative of y with respect to time. So therefore 2 meters per second is the derivative of x with respect to time. Now what is the derivative of the length of the ladder? Okay, for this case the derivative or dz dt is equal to 0. Because even if the ladder is sliding down, the length of the ladder will not move with respect to time. Therefore, the derivative of a constant is 0. As you can see here in our illustration, we have a right triangle. So we can use the formula for the Pythagorean theorem so that we can identify the value of x when y is equal to 4. So let us have, so since the variables that we use would be x, y, z, then we have x squared plus y squared is equal to z squared. So we would like to find the value of x squared. So y would be 4 and then squared is equal to z is 14 and then squared. Therefore, we have 196 minus 16. So we have x squared is equal to 180. So getting the square root of both sides of the equation, we have square root of 180. The simplifying factors of 180 would be 36 and 5. So x is equal to 6 square root of 5. So let us perform implicit differentiation to this equation. So the derivative of x squared is 2x, then multiply to dx dt, plus derivative of y squared is 2y, dy dt is equal to 2z dz dt. Multiply all the terms by 1/2. So we can have x dx dt plus y dy dt is equal to z dz dt. Since we're looking for dy dt, we can have y dy dt is equal to z dz dt minus x dx dt. So we have subtracted x dx dt to both sides of the equation. So to get dy dt, that would be z dz dt minus x dx dt all over y. So this is how we get the value of dy dt. So let us now solve the value of dy dt. Z, or the length of the ladder, is 14 meters. dz dt is the derivative of the ladder with respect to time, minus x, that would be 6 square root of 5. And then dx dt is 2 meters per second over y, and that would be 4 meters. And then we have negative 6 square root of 5 times 2 is negative 12 square root of 5 over 4. So this can be simplified as negative 3 square root of 5. So this is our dy dt. Do not forget to write the units, and that would be meters per second. Or this is approximately negative 1.68 meters per second. Notice that our answer here is negative because as the top of the ladder slides down, y value decreases.